Okay, thank you. Principle 7, the ocean is largely unexplored. The ocean is the largest unexplored place on Earth. Oceanography is a science that many different sciences intersect as mathematics, physics, chemistry, biology, and geology in order to study the ocean. Therefore, it is an interdisciplinary science. The foundation of oceanography was set by the Challenger expedition that lasted from 1872 to 1876. This expedition made the scientists realize that the ocean was full of life, complex, and with unknown resources. Have we progressed a lot in ocean exploration since 1876? Not really. Most of the ocean still remains unexplored. Why is that? Well, ocean exploration technology has evolved only the last few decades, and exploration at great depths, over 200 meters, is not an easy task. So we could say that scientists know more about the surface of the moon than about the great depths of the ocean. Why do we need to explore the ocean? Just to satisfy our curiosity? Of course not. Exploration, experimentation, and discovery are required to better understand ocean systems and processes, to learn more about various aspects of the ocean in order to manage it sustainably. We cannot manage the unknown. And if we want to explore, first we have to map. As of 2023, 25% of the global seafloor had been mapped by the Seabed 2030 project, which is an initiative about mapping the entire seabed by 2030. Also, if we want to explore, we need new technologies, we need new sensors, we need new tools, satellites, drifters, buoys, subsea observatories, and unmanned submersible vehicles. These are expanding our ability to explore the ocean. On the left, you can see an autonomous robotic float. This float can descend in a depth of about 2,000 meters, make measurements, return to the ocean surface, and transmit these measurements to a satellite. And there is an educational program where you can adopt one of these floats. And a school project like that could be very well connected to science, technology, engineering, and mathematics. There is also an underwater robotics student competition by NASA, and it's about designing and building a remotely operated vehicle, a ROV, and the necessary sensors, tooling, and complementary technologies to monitor the health of marine habitats. New technologies can use old technologies. For example, in this submarine, in this map, you can see cables, submarine cables that they are used for telecommunications. But now scientists investigate whether they could use these telecommunication cables to track mammals, monitor earthquakes, volcanoes, and ocean waves. The use of mathematical models is an essential part of the ocean systems, as a mathematical model is a description of the ocean we cannot see. So models helps us understand the complexity of the ocean and its interaction with the Earth's interior, with the atmosphere, with the climate, and with the land masses. Mathematical models can also describe interactions with ecological food webs. They can help us predict and prevent species extinctions. No need anymore to measure phytoplankton diversity. Quantitative modeling can do that. And as you all understand, the ocean exploration is a truly interdisciplinary. Different scientists, as biologists, chemists, climatologists, computer programmers, physicists, animators, and illustrators collaborate. And these interactions foster new ideas and new perspectives for inquiries. On the left, you can see a 3D model about calculating the volume, the body volume of free-range marine animals. So we have the knowledge, we have the means to protect the ocean. Will we be able to protect it? Only around 1% of the high seas currently enjoy protected status. And this 1% corresponds to the National Economic Exclusive Zone in 2023. A high seas treaty was signed in New York. This high seas treaty is about the common governance of about half of the Earth's surface at about 95% of the ocean volume, and it's a very good opportunity for the establishment of new marine protected areas. Of course, Principle 7 is also connected to SDG 14, EU priorities, EU missions, and the UN decade. Some more inspiration for Blue School projects. You can use the European Atlas of the Seas to describe the state of the coastline in your country. You can also use, you can also build your own turbidimeter, and you can be inspired by several European Maritime Day projects. This is the conceptual flow diagram for grades 3 to 5 for Principle 7. And this is pretty much all I wanted to say about the last ocean literacy principle. Thank you so much for your attention.